Hi everyone. My name is Anna Mladentseva. I am an embedded doctoral researcher at Victoria and Albert Museum and also software conservator. My home institution is University College London. And today I'll be speaking on behalf of myself and Natalie Kane, who is curator of digital design at Victoria and Albert Museum, on the project that I've been working on together with Natalie. On conserving a mobile app using emulation, and the parts of this project forms part of my doctoral research. I did want to provide a content warning ahead of my presentation. Due to the nature of the app that I'll be talking about, there will be references to abortion and women's reproductive rights. So to summarize this presentation, firstly, I'll introduce the acquisition and outline the chosen method for emulating mobile hardware, summarizing the possibilities and limitations of emulation as a conservation technique. And then I'll look at this method in the context of the larger institutional and knowledge infrastructures to illustrate the sorts of challenges this work presents. And by work, I mean not only the mobile application, but also this type of conservation work. So some of you may not be familiar with the Victoria and Albert Museum. Some of you may be familiar with the Victoria and Albert Museum and may know it in terms of some of the other objects that we have in the collection, such as fashion. But actually, digital art and design has formed part of the collection since the 1960s. Now, if we're talking about complex digital design, such as mobile applications, these types of objects were established in the collection with the formation of the Design, Architecture, and Digital Department in 2015. Following some restructuring, this is now called the Design and Digital section that goes under the larger umbrella of art, architecture, photography, and design, with a focus to collect design and society. The application that I'll be talking about is not the first mobile app that the museum has collected, and there have been previous app-based acquisitions in the museum, including the mobile game Flappy Bird in 2014, and collected as an Android application, WeChat in 2017, and there's also one iOS application as well. So before this project, the care for the apps has mainly consisted of depositing and preserving the application files on the museum's digital asset management system and partially on various carriers and stores, depending on the project. There have also been some efforts to revisit some of the past acquisitions, including WeChat, where, for example, the video documentation walkthrough of the app was elevated to the status of a collections object. So the actual video documentation of WeChat, the application, has the same status as the APK file of WeChat. And recently, we've developed a more formal approach to our acquisitions, digital acquisitions, including standardized technical questionnaires and interviews. And the museum's interest in kind of rethinking some of its care really comes from a very key moment in the museum's time and an interest to participate in research and knowledge exchange. Perhaps some of you may have heard of this quite large project that the museum was involved recently called Preserving and Sharing Born Digital Objects, which goes from more experimental approaches to the acquisition of complex digital objects and the move towards collecting auxiliary objects that accounts for process and documentation. So this is just to say that it's a really exciting time for the museum at the moment, as the internal infrastructure and knowledge is rapidly changing, in part due to these projects. So moving on to the case study. So today I'll be talking about a mobile app called Yuki. It is a period tracking and sexual/reproductive health app collected by the museum in 2023 as part of the Rapid Response Collecting Initiative. This initiative collects objects that respond to current affairs. So in this case, the app was developed by the Women Helping Women charity and IBIS Reproductive Health because they wanted to develop an app that promises to safeguard users' data and is privacy first. Now we're talking about a time where when Roe versus Wade was overturned in the US and accurate and accessible information about abortion was under threat and women's rights were also under threat. So there was an interest within the museum to collect an application, the design of which speaks to this historical moment in time. To illustrate some of the motivations behind my research, the application was collected as an Android application, as an APK file, which is the Android package format for mobile applications. And at the moment, museum stakeholders within the infrastructure that exists in the museum can only access the APK file through dedicated stockpiled mobile hardware, so several Google Pixel smartphones. The obvious downsides to that is that mobile hardware is incredibly difficult to repair. And if we're thinking about access and scaling that access to various museum stakeholders, such as curators, registrars, conservators, and even members of the public or interested research, it's quite difficult to scale this access to several people when you're relying on a finite amount of hardware that you have in the museum. And in turn, if you rely on this hardware for access, you are nonetheless contributing to the wear and tear of those of that hardware, which is why, and this is where I come in. I've been exploring whether the application, Yuki, can function as intended on non-mobile hardware as part of my practice-led PhD research. And the non-mobile hardware platform of choice is Intel x86, the dominant instruction set for now in most desktop computers, except Apple, of course, that have moved towards ARM-based M1, M2 processors. So the way that we can make this happen is through emulation. And some of you will be very familiar with emulation. Maybe some of you are not as familiar with it. But generally, when we talk about emulation, we use it as a catch-all term to describe the simulation of a computer system on a different computer system. Practically speaking, there are varying degrees of emulation. So a given virtual machine can either fully emulate hardware components or access some of the host machine's hardware via an implemented software layer. This is called power virtualization. And the latter option of power virtualization is a more computationally efficient solution, and sometimes it's as efficient as running things natively on the hardware that you're trying to emulate. So when it comes to emulating something like a mobile computer system, there are two options. You can either fully emulate mobile hardware, the majority of which contains CPUs with the ARM64 instruction set, or you can access some of the host machine's hardware. In this case, we're talking about Intel x86-based hardware through power virtualization. But then how can we go for option number 2, which would be the more computationally efficient option if the Android mobile operating system and the UK application have been developed for CPUs of the ARM64 instruction set and not for x86? Well, from my research, I've found the Android x86 project, which is an open source project to support the Android operating system to Intel x86 platforms, which essentially allows us to install Android on a power virtualized virtual machine through something like VirtualBox that has access to the host hardware and, most crucially, the processor's native instruction set. Now, regarding the application, this includes the native bridge, which is a solution from Google that is able to run applications with ARM native libraries on x86 platforms, essentially translating them on the fly. I found through doing this emulation exercise and synthesizing the disk image that emulating mobile hardware using the Android x86 project has promising results, at least in terms of accessing the application in a reading room type of environment or behind the scenes for staff. But I must admit that the level of fidelity is perhaps not good enough yet to replace the original mobile hardware for exhibition and display display purposes. Now, this is something that I'm kind of working on, so maybe in the future it will be good enough. Disk image that this static disk image that I'm producing and the overall software package will be good enough to replace to be used for exhibition and display. But at the moment, further work needs to be needed for a display setup that is able to map touchscreen inputs with cursor input. As part of this project, we have also noticed that the app has already suffered loss despite being collected last year. So the application contains a number of hyperlinks leading to web resources, some of which no longer exist. This is particularly the case in a section in the app dedicated to personal stories on abortion. The app has a snippet of a story that you can continue reading by clicking on the link, and as you can see in those screen grabs, not all of these links are live. After doing some investigation, I found that some of these links are the result of link rot, and there is an equivalent updated web link available online. But in other cases, the stories have been removed from the web completely, and I could only find traces of these web pages on the Internet Archive. Of course, this raises questions on the ethics of potentially restoring access to these web resources that have been removed completely from the web, from the live web, given their sensitive nature and potentially lack of consent from these individuals who may not know that their stories remain as part of a mobile application that is preserved in a national collection, despite them, for example, asking for the story to be removed from the internet. And this brings me to discussing some of the challenges that this type of work presents, which is based on the fact that we are unable to preserve something forever, like a mobile application, using one single method, which means that the boundaries of care around the objects are going to continuously shift. And this is something that some institutions are not prepared for. As I mentioned, this method of emulating mobile hardware using the Android x86 project has promising results, at least in terms of providing access. Although because computing architecture is likely to change and is already in fact changing, it is unclear how long this method and the resulting software package that I've been working on will be able to last and remain useful to the museum. So the museum therefore needs to be equipped to adapt to changing technologies, developments in emulation research, and emerging community-led initiatives such as the Android x86 project, which emerges primarily outside from a gaming interest, people who are interested in playing mobile apps, for example, on their PCs, and they've been contributing to this project. To be able to reproduce at least parts of the method or find equivalent alternatives. And this is not to mention that as time passes, engaging with infrastructure such as those listed in the previous slide becomes increasingly challenging, if not impossible. And this is especially the case if technologies lose their relevance and generally have less resources allocated to them. And it doesn't help that besides the community-led Android x86 project, my chosen emulation method makes use of various external tools, normally provided and maintained for Android software developers, such as the Android debug bridge and various command line tools. An example of such command line tool is APK Analyzer, which is a Java program that comes in the Android software development kit. And this can be used to extract and decompile the binary XML manifest file of an APK. And this manifest file contains a lot of useful information, such as the minimum and target versions of the operating system the APK was developed for, which makes setting up an emulation environment for this application much easier. And another example of a tool is the Android debug bridge, which is another tool that comes with the Android SDK, which can be used for communication between the host and the virtual machine. And in this case, I used it to onboard the APK file into my virtual machine environment. So it seems like the role of the institution therefore becomes enmeshed with essentially working with communities of practice. And there's two primary communities of practice that Natalie and I have identified. The first one being the communities of practice that Natalie works with primarily, which are object originators. So in this case, it would be not only the organizations that created the app, but also the individuals whose stories are represented and the role that curators have to represent these communities through their objects. And on the conservation side of things, we have open source communities such as the Android X86 project and industry actors that directly benefit the object's conservation. And as we have seen, these are not straightforward relationships and they do not provide straightforward answers. As in the case of defunct web links, we have the question of whether we can accept this loss given the sensitive nature of the content. And in working with open source and industry actors, should the museum be elevating, like in the case of that WeChat documentation, parts of the access package for Yuki? Would that not be incredibly challenging, given that institutional policies operate, at least in the V&A, on a custodianship model that assumes beneficial ownership? And without ownership as part of that equation, as in the case of open source projects, should institutions be looking to change their policies to engage with these communities in a more meaningful way? And of course, it's difficult for an institution like the V&A to be too radical in its policies because we are bound by much larger governmental bodies, like, for example, even just the National Audit Office. So this concludes our talk. Thank you for listening, and I'll try to answer any questions that you might have.
Thank you, Anna. Would you like to mention maybe your colleague who's not here? You were mentioning we did, so...
Yeah, so as I mentioned in the beginning of my presentation, yes, as I mentioned in the beginning of my presentation, this work has been done with Natalie, who collected the application that I've been working on, and she's curator of digital design at the V&A.
Okay.
Did you also consider evaluating the emulator that comes with the Android Studio, which also runs on the same platform, and from my experience, which is running much faster than the X? Yeah.
It does work much better, but I don't really see how this could be, for example, used in the museum's context, especially given that the Android Studio, I'm not sure whether it's an open source application and whether, for example, we can use the emulator separately. So it just makes sense to create a package that can be understood and almost controlled better, rather than relying on something like Android Studio. But I agree that the emulation there runs much better, but I'm planning in the future of exploring some forked versions of the Android X86 project. I think there's one project called BlissROM, so it's something that I'm hoping to explore in the next few months. Yeah, maybe that'll look and run better. Yeah.
Hey, thank you very much. So sorry if I missed this, but I was wondering if you could explain a little more about the data privacy features of the app, and if you noticed any compromises during the emulation of that, and if the link route had anything to do with that.
So the data privacy issues are basically the reason why the app was this. The way that they're doing this is by basically not storing any information on servers, and the information is simply stored on your local device. Plus, in terms of the design of the object, there are additional features, such as you can have you can basically password protect your application, and the way that in the application you have several information tiles that you can work with, and you can, for example, hide some information tiles, and then, you know, basically, so someone is looking into your phone, they can't see that you're accessing this sort of information. So the privacy first approach comes less from it comes more from the design aspects. Yeah, hopefully that answers your question. Yeah.
Hi, Anna. Thank you for the wonderful presentation. I'm Gina Chang from the National Museum of Norway. I have a question regarding the acquisition process about this mobile app. So what actually acquire as a museum when you say mobile application? So what does specified in the contract, you know, what do they can actually come into museum? Because especially it has kind of linked account if there's some apps running this kind of user board or whatever, does it involved in the specified in the contract or those kind of things?
Yes, so it's just the APK file that is being acquired. There is no, you know, it's a empty APK file. There is no user data. And I mean, this was actually something that I was thinking about earlier, whether there's a need to almost simulate, based on this APK file, some kind of dummy user data. But in this case, it doesn't make sense because the whole point of the app is that it's privacy first, and you wouldn't want the app to be populated with anything. So it's just the kind of the executable application that is being acquired, no user data. And as I mentioned in my previous answer, when a user uses the app, all the information that they enter on it is stored locally on their device. So on a different device, you know, that information kind of doesn't transfer over. Yeah.
Thanks for your presentation. Have you developed any criteria to inform what's an acceptable amount of loss when it comes to these apps or other complex works you're collecting?
Yeah, no, that's a good question, and that's something that I guess I pointed to in the last slides in my presentation, that it's quite difficult to gather what acceptable loss is, and it's always going to be different depending on the context of the app, because in a different app, these expired web links wouldn't have been accepted, right? And we would have had to preserve them. But in the context of this app, maybe it makes sense to actually let these links expire and think about how we can communicate this as an acceptable kind of loss. But there isn't like a set criteria that we have in the museum for approaching this yet.
I have a question. So regarding your kind of like call for the institution to maybe kind of open a little more to the community and stuff, would you have any, say, fantasy about like how this could happen, what the institutions could do?
I mean, yeah, I've been thinking about this a lot, and I think it makes sense, for example, for the institution to start from just even simply collecting these tools, not collecting them as collections object, but storing the binaries for the Android debug bridge or the command line tools or the software development kits. If that's legally possible, I feel like it should be. But I don't know whether that's actually enough to just simply kind of store these things within the institution, store this knowledge within the institution, which is why I've kind of hinted towards what happened with WeChat, with the documentation being elevated to the status of the collections object. I'm thinking, could maybe, you know, an emulation package become a collections object, but perhaps not, because that would make it very difficult to then redo this type of work, because when something becomes collections object, you can't get rid of it. There's very specific rules that you need to follow when you're trying to deaccession an object. So I think that maybe there needs to be something in between simply storing these things within like DAMs or like an alternative system, and in between making something a collections object. But I don't know yet, and that's kind of part of my broader PhD thinking. Yeah.
Wonderful. Thank you very much, Anna, for your presentation.